Well, hello everybody. So I give you a presentation of the framework for analyzing a malware called Disass. So who am I? My name is Fontarensky. I'm working in the CCR team in Cassinian Cybersecurity. A big part of my job is incident response and malware analysis. So I built a lot of tools on this topic, and I belong to other community as YAR. Maybe someone know what is YAR. Very good community. Why we build Disass? Because Cassinian Cybersecurity works for a European project called ACDC. We saw it and we talked about it this morning. And in this project, we received a stream of malwares, and that we will analyze, and we try to extract valuable information from this all these malwares. We receive a flow of malware from other partners, and during an incident response, we find many malwares. Sometimes it's APT malwares, and we need to make an efficient response. We need to extract really quickly the information. So that's why we wanted to make a framework for that. But because the problem is here, when we try to make a basic script, it's not strong enough, because when we make my script for the first time, I want to apply it to another samples, and it's not really working because sometimes there is some changes, so it's complicated. So Disass is a framework that automates the work of reverse engineering. It's written in Python 2.7. License under GPL v3, and it's based on two other tools. Distom3 by Disass. It's a linear disassembly engine, and Purified by Aero Carrera. So to be clear and to avoid the confusion, Disass is not another disassembler, nor a debugger, not an emulator. So what is it? And that's far from all of that. The main functionalities, when I make Disass, I wanted to make to have some human readable script, and can read the script really easy and understand what I want to do with that. So that's the first purpose of Disass. And I have an interactive shell to make my script with it. We can navigate inside the binary and evaluate a register at a specific position. So interesting feature. And we can follow the branches, many branches, when we have some jump, some call. So we can find inside the binary to find some data. We have another interesting features, because we are using a Distom. We can jump in the middle of opcode. So this is very interesting, because when we have some obfuscation, we can understand, and if we can explain in the script, it can bypass, it can understand the obfuscation. So all these functionalities, we try to make something resilient to a malware evolutions. So just a basic script, basic assembly. Here we have some interesting fact. We have a string, a mutex, create mutex code are called inside this malware, and we want to extract the value Alan. So if I have made a basic script, I can do like this in Python. I'm searching something, this value inside my binary. So here, and I find this pattern near Alan, and I say, okay, I search where is this value, and I take the string before this one. But it's not very good, because if I have another, if I use another compiler, if I have some changes in my code, if the developer wants to fix some bugs, my script didn't work. So it's not good. With Disass, it's very more easy. I just explain, open my malware, so Disass32, open malware.exe, go to the function called create mutex, give me the third arguments, and give me the string to these positions. And that's all. And I have the mutex. So easy. Sometimes in some malwares we can have a thread, and inside this thread we have some malicious code. So this is interesting to go inside this thread. So we can we ask to Disass to search where is the correct thread, get the arguments, the third argument, because this is the address of the thread, and ask to Disass to set the virtual position inside this thread. And we are in this thread. We wanted to get the CNC because when we have a malware, we want to know some valuable information, interesting, some the CNC, the mutex, some many things. So we ask to Disass to go to the internet connections, ask exactly the same things, extract the arguments, give me the strings. That's all. So very easy, and we can understand very fast a script, and we can make some easy script. I will show you with the demos more. Okay. Okay, so I launched my interactive shells. I have a malware here, so it's a Minjat. It's an interesting malware because it's used by an APT group in this moment. So I did okay, good. I have set verbose true though, so we can see the assembly for the moment. So it start to reverse, and I say, okay, now Disass, I want to go to the next. Where is the next call of correct thread? Okay, okay. So he's searching the value of correct thread. Okay, I ask him to give me the address of okay, stat address. I ask the third arguments. Set virtual positions. So inside this thread, I go. Okay, I am the thread, and now I want to see what I have in this thread. So, oh, I know I have. Okay, this is the code, the assembly of this my thread. Here I can see the CNC. So I want to get this value. This value is there. Okay. Is used by this function. This function is EBX. So, okay. I ask it, Disass, go to next call of these functions and give me the arguments. Get strings. Okay, the second argument, so I'll show it. And that's all. We can get the CNC very easy, as I can show you. Thank you. So I have you can download the code I will give you that for that all the framework, and you have here in this folder you have some samples to test to make your own script. So I'll show you another example of script. So I have to show you on many malwares. So samples. So what I want to take, okay, the agents. So just for an example. Huh? Yeah. Okay, so it's working. It tried to identify in the script exactly the same commands, but I just type every command. It extracts the mutex because it's an interesting value. Sometimes it's the name of the company of an attacker. It extracts the CNC, extracts the user agent. If it can detect all the URL used by the malware, extract it. So here we can see. So we can see now on this domain, it try to reach this URL. So very easy, and it's very efficient. And when we have many malwares in the same family, the same script can work. Okay. So Disass script versus malware evolutions. If the developers wants to change the CNC, it's not a problem for Disass because it's just minor changes. It's not a problem. If he wants to fix some bugs, and there are many bugs in some malwares, so it's not a problem because it's minor changes. If he wants to add new features in malwares, it depends. Because sometimes he can add some interesting function with the same call I wrote in my script, so it depends on the features. But Disass is not, the job of Disass is not to unpack or to encrypt. If I want to do it, I have to map with some kind of these routines. So not very difficult for that. So just an alpha release for the moment. Disass works for just x86, and you can download the all the framework here. Do you have some questions? Yes.
If I understand well, you're relying on the DLL imports to name the function. If it's statically linked, do you have a mean to?
Yes, you have. I try to resolve not for each case, but I try to resolve the links inside the malware, so it works for that. Some other questions?
Okay. Thank you. Thank you very much.